Hello and welcome to Cannon County High School Algebra 2. Today we're going to take what we did yesterday and expand on it just a little bit, and we're going to actually calculate some regression lines, linear regression, on the IXL. So we're going to do EE6. So today, EE6. That's what we're gonna do. Ooh, sorry, Mr. Lyon, that wasn't very nice of me. I apologize. We'll talk to you at the end of the video here. So let's take a look at that. Let's see here. All right, here we are. EE6. Zoom in on that a little bit. We're gonna do the same thing we did yesterday. We're just gonna let the calculator do the work for us today. That's all. So let's see what this says. It says, find the equation for the least squares regression line of the data described below. A food scientist wants to understand how much sugar children like in their desserts. She sets up a study where the children taste cups of vanilla pudding with varying sweetness and rate each cup on a scale of 1 to 10, where 10 is excellent. For each tasting, the food scientist writes down the number of grams of sugar in the pudding cup, X, as well as the rating, Y. All right, so they give us a table, and it says round your answers to the nearest thousandth. Okay, well, yesterday we kind of did this the hard way, where we actually graphed each one of the data points, and then just by hand, we kind of figured out where we thought the linear regression line would be. We picked 2 points, and then we used a little Algebra 1 to calculate what the line of regression was. And then at the end of yesterday's video, I showed you how to use the calculator to come up with the exact best equation of the regression line. And that's obviously what we're doing here because we're trying to find to the nearest thousandth. So it really boils down to plugging these numbers into your calculator and letting it do this for you. But this is something that it's good to know how to do. So we're going to talk about how to get the calculator to do this. We're just going to try a few and then turn you loose and let you enjoy your summer, because this is our last video of the year. So let's see, 13.1, 16.4, 23.3, 24.5, and 27.6. Let's go back to the calculator, and I'm going to zoom in a little bit more. I'm going to try to keep it all in the frame today. Yesterday I was talking, I noticed on the video that some of the things I was saying wasn't even on the video screen because I can't see the screen from where I'm talking from. So I'm gonna try to do better with that. First, you wanna hit which button? Stat, this one right here. So you wanna hit the stat button. All right, and notice that the very first thing that comes up is edit. Now when I hit enter, you'll see I already have things entered here, so I have to get rid of those. And I've noticed that the clear button doesn't help in this regard. You have to use the delete button. Maybe you can find a better way to do this, but the delete button, which is right here, is I have to go to each cell, highlight each cell, hit delete, and then move using the arrow keys. So the way I've found that this works, if I go up, let's say to that cell, if I hit the delete button, there we go, it deletes it, and it brings up the data so it makes it quicker and easier to delete. So I'm just going to delete all those, move over here, delete, 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 delete. Okay, so make sure all of those are gone. Now all I'm going to do is enter that data right there into those two lists. So do that first. Okay, and then I use the right arrow key. Have to hit enter first. It won't let you just use the arrow key. And then let's see, 1, 4, 3, 5, 6. Hit enter. Make sure you hit enter after the last one. All right, once you get that in there, notice we've got L stands for list. So list 1 and list 2. Now if I hit the stat button again, so again I'm hitting this button right here, hit the stat button, and move it over to calculate. I'm going to choose choice 4, which is linear regression. So choose choice 4. And look at what it's asking. It says, do you want me to use the X list as list 1, the Y list as list 2? We don't really care about the frequency list, or I don't even know what that means. All you have to do at this point is hit enter. And on your calculator, you're gonna have to scroll down, but on my iPad, the screen's a little bit bigger, so I don't have to. But this is the slope, this is the y-intercept. And again, this right here, R, is the correlation coefficient. Remember we said yesterday, the closer that number is to 1, the more perfect our data represents the line. So this one's not too bad, but they're not even asking us to graph this. They just want the equation. So here it is. They want us to round to the nearest thousandth. So this would be y equals 0.266 or 0.267, because the 7 would round that up to a 7. And this would be negative 1.695 for the y-intercept. So that's really all you have to do. You just have to type that in. So let's see here. Can you see that? Well, you can't quite see that. I gotta zoom that in a little bit. Zoom this out a little bit. There we go. Okay. So right here is where I'm going to put the 0.267, and right there is where I'm going to put the y-intercept, which is negative 1.695. And we got it right. Okay? So that is how you do it. That's really all there is to it. So remember, when you go in, let's say this is the next problem that you were going to do. Here's my new data. Okay, this time we're in a political science class and we're looking at approval ratings. Remember, when you go here and you hit stat and you hit edit, remember, you have to get rid of all these first. So you're going to have to go in and by hand, use the delete button and delete each one of those and clear those off. That's kind of a pain in the butt, but that's the way you're going to have to do it. Okay? So that's what we're going to do. And linear regression is great. It can be used to predict things. For instance, let's say there was some virus out there that was causing all kinds of havoc. And let's say back in January and February, you looked at the number of cases of this strange virus, and you noticed that in January the numbers were here, and in February the numbers were here. And so then what you do is you use linear regression and you say, well, that means that obviously the number of cases is going to do this. But you got to be careful, because not everything is linear regression. Back in January and February, we could have said, well, the number of cases of this strange virus that's infecting everybody, it looks like it's going through the roof. And it looks like by March and by April and by May, we are going to be in some serious trouble. But if the data back here says that it looks like it's a linear regression, remember there were some things on here that were not linear regression. Let me look here. Stat. Calculate. Some of these things that are grayed out, remember this is the free version of this calculator, so it's not going to give you everything, but quadratic regression, cubic regression, quartic regression, and so on, exponential regression. There are lots of different ways that data can present itself, not all linear. And if you look, what happened maybe is this. Maybe the virus slowed down and it's starting to go down. And what does this look like? Yeah, that looks kind of like a parabola that's upside down, that if you were mathematically going to extend it, it would go down in both directions. And maybe this was really quadratic regression and not linear regression. That's where that correlation coefficient comes into play. As you get further and further into this in higher math classes, you'll be given data and will not be told necessarily, is it linear regression or is it quadratic regression? Is it exponential regression? You'll have to do that yourself, because I think you can see that if we were to take the data and say, well, yeah, mathematically it looks like the cases are going to keep going up forever, that's not really what happens in the real world all the time, and you can make some pretty bad predictions that can really mess up a lot of people's lives. So anyway, enough about that. Remember, this is EE6. Zoom back out. EE6, give a few of those a try. Now notice it says the mask comes off. So Mr. Lion, I said we were gonna do this. Let's see, how is this thing attached back here, Mr. Lion? We gotta let you free. This is ridiculous. We've done this long enough, isn't it? Okay, here we go. Let's see, oh yeah, you got tape back there. Oh, Mr. Lion. You look familiar, Mr. Lion. Are you an actor? Have I seen you in a movie before? Are you sure? No? Okay, well, Mr. Lion would like to wish all of you a happy summer. And also, I just wanted to say as well, I really appreciate those of you who have been watching since the beginning, because this has all been suggested practice. You don't have to do it. And I think it says a lot about you as a person and as a student that you're still trying to learn, even though you don't necessarily have to for a test. So really, really appreciate it. I hope you all have a great summer. It's been my pleasure to do these videos for you, and I will see you in the fall, I hope. Bye.